The final thing that I just want to show off as part of this is the database. Now, the database is obviously quite key to my piece of automation and the implementation that I've actually done. And it basically links everything together. So we have, to start off with, the device table, which in this case I've included within it the community string that's needed for SNMP, because I use that a lot. I've got the username and the login passwords. I've got the enable passwords in there as well, just to speed up the development. I use just plain text credentials, nothing like SSH keys or anything along those lines, because if I'm honest, I'm not an expert in those kind of things, and if I were to implement this in a real life scenario, I would most likely have to engage someone else to actually help out with those kind of things. As part of that, I've also then got the IP address of the device. So that is the router ID that I've assigned to each device. I've then also set a loopback with that relevant address on each of the devices, just to make sure that it's reachable, because that is the IP address that is used to gain access to the devices. As part of this, we're also identifying the vendor, because when it comes to then the configuration side of things, we need to know whether it's Cisco or whether it's Juniper or whether it's something else completely. Because if it's something else completely, or if it's Juniper or if it's Cisco, we need to do different things. So with the case of Juniper, we're using the API with XML that we're passing into that. And then with Cisco, we're using pure just an SSH connection with then the commands sent over that SSH connection. As part of this, we also have a config lock. That just basically ensures that while one task is executing for a device, another task can't come along and try and execute on that same device. Now, inside the scripts that I've got, I think it's on the inside the common tasks file. We have the functional code for getting a config lock. And now inside that, we actually do attempt for a number of times. So I think we attempt 3 times with a wait period of probably about 5 to 10 seconds between them. That's just obviously so if we do trigger some automation, we're not just going to fail instantly if the config lock has been gained by something else. And there's probably some better automation that I can do around that. Better coding that I can do around that, because I believe with some of those config locks, it doesn't actually just lock around the time of the configuration. I think it also locks around the time of when it's actually checking, which could be an issue, might not be. I guess it all depends on the scenario and actually what you're actually trying to automate. And then as part of that, we also have the ASM, which is helpful for the BGP configuration side of things. As part of this database, we also have a tool log, which will identify the tool that was called, the timestamp, the user, whether it was a success, and then the variables that were used, or any state that needs to be passed back or logged as part of the script running. So as we can see with the dprefer tool, we identify the host, the interface, and the cost. With the update of interfaces, we're identifying how many interfaces were updated, how many were added, how many devices were unreachable. With the approval of BGP peers, we can actually see what peer IDs were configured, which were approved. And then when we actually configure them, we're identifying which IDs were actually configured, which ones were checked, and things along those kind of lines. So from this, if we really wanted to, we could then pull out statistics, and we could then start to do some analysis of the executions to identify really what's actually going on in the network. Because obviously in this case, throughout my testing and my demoing, I've gone through 1,742 tasks, but you could very easily go through that within a minute, an hour, a day, with this being ran on a normal live production network. So to be able to pull those stats out and identify where tools are not working properly, or to identify how tools are being used the most, this is pretty helpful for those kind of things. As part of this, we also note down the interfaces that we have on devices, which identifies the device that it came from, the actual name of the interface, the description, the IP address, the state, when it was last updated, and then the traffic counters and the speed. Now this could be used for, let's say, a web front end or something on those lines, so you can actually visualize what interfaces are on what devices, the states. But obviously this project is more focused on actually the automation, so the back end side of things, rather than trying to create graphical user interfaces. But obviously from this, you could create, let's say, a web front end to identify devices, and then under that device, so obviously devices would come from the device table. You could then, inside the device table, inside a specific device that you've selected, identify all of the interfaces that are linked to that device if you really wanted to. But obviously this is then mainly used currently for the traffic counters. So it'll identify the counters on the interface of the amount of bits out on that interface. Now that counter is a 64-bit counter, and it is counted in, I believe it's bytes rather than just bits. So when you do the calculation, you need to take that into consideration as well. Another table that we have is also the Syslog Events. So obviously with the Syslog server, we are also monitoring all of the Syslog messages that we're receiving through. As you can see, there's been quite a few. Towards the bottom, we actually see where most of that is. And I've done some stress testing on that. There is some limitations with the MySQL database, which means that we can only allow, I think it's 150 connections at any one time. But I'm sure someone out there might be able to figure out a way around that. There's also some limitations on the amount of data you can pull back from Python in regard to the database as well. If you want any more details on those kind of things and what I actually tested, you should be able to see that inside the dissertation. Inside section 8.10.3, there is a bunch of stress testing that I go through for the Syslog receiving data from the network. We then also stress test the database, and then we also stress test SNMP on a few devices as well. So that is everything from the database point of view. Obviously, if you wanted to implement some of these automation tools independently without the use of the database, you can. But obviously, you start to lose some of the functionality, some of the things that are in there to check things and verify things. As part of that, you might also need to either statically define values, or you might have to take more values in via the command line. But obviously, if you start to remove the sources of data storages, then obviously that's to be expected. So hopefully that all makes sense. There should be the files that were created from a data export from the MySQL workbench inside the overall folder. So that should allow you to import them and then recreate the actual database that I have here in front of me.